Okay guys, welcome. Today we are taking a look at applications or word problems that involve quadratic equations. So a few steps here that you need to consider when you're doing these questions. First off, it's important that you read the question carefully. So it's always a good idea to reread it and make sure that you've got all the information that you need. Just hold on, I've got a phone call here. Oh, it's my daughter, one sec. Hey Annie, how are you? Hey, what's going on? Don't ever have kids. They suck the life right out of you. Okay, back to math. So next, you want to decide what we're trying to find and declare your variable. So in some questions, it'll be obvious what the variable is. It's kind of given to you. In other cases, you have to create the equation and the variable as well. So next, once we've decided what we have to find out and what the variable is, we set up the equation. Once the equation is set up, we need to get it in standard form. So we're going to expand and simplify and get one side equal to 0 as needed. And then we're going to solve that equation. So in a lot of cases, in most cases, we're going to be using either the quadratic formula or factoring. And we know that when we solve these quadratic equations, that we often end up with two answers. So in these questions, because they're real world problems, we need to check and make sure that the answers make sense. So in some cases, you may get something that is inadmissible. And you'll see in our examples what that looks like. So when we do these questions, you're probably going to recognize some of these types of questions, and you might say, hey, we've already done these before. The questions that we did previous to these that seem similar are questions where we were working with maximum and minimums. So in those questions, we were focused on the vertex of the parabola. In these questions, we're going to be focused on the x-intercepts. One type of problem that we get is when you are given an equation already. So we'll start with one of those. The flight of a soccer ball is modeled by the quadratic function. So here we're given the equation. H represents the height above the ground. So that's what H is. It's in the y spot. And D is the horizontal distance. So that's the one that is in the x spot.
Miss Ellis, you have a call on line 1. Miss Ellis, line 1.
Not Miss Kellis, she's so popular. Now, I'm throwing this question in here because these are like the questions we did before, where you see maximum or minimum in the questions. So we're going to go through this, but then the rest of the questions we do will be new questions involving x-intercepts. So if I gave you this question and asked you to find the maximum height that the ball reaches, we need to find the vertex. Because as we know, the vertex contains the maximum or minimum value that we're looking for. So we're going to use the little formula. So x is equal to minus b over 2a. So x is equal to, b is equal to 1, and a is equal to negative 0.025. Just make some room for that. Okay, so there are my A and my B. And there is no C value. So C is equal to 0. We just need A and B here for the little formula. So this is going to be negative 1 over 2 times negative 0.025. So it's going to look like that. And when I calculate and do that division there, I end up with x equals 20. So that's the x part of the vertex. Now I'm going to sub that into the equation up above. Now I'm using x here. Remember, x is where the d is. So we're trying to figure out what the maximum height is. So h is equal to negative 0.025. And then I put x in where the d is there. So 20 goes in where the D is there, and 20 goes in where the D is there. And when you do this calculation, you come up with 10 for the value of h. So the vertex of this parabola would be 20 and 10. So here we would say, therefore, the max height of the ball is 10, and this is being measured in meters, we'll say. Okay, so that's a question that hopefully you recognize doing before. Now we're changing things up. We're going to do questions where we're trying to find the roots or the x-intercepts of these equations. So for this one here, how far does the ball go before it hits the ground? I'm just going to draw a picture of what the parabola might look like here. So along the bottom here is the D value, because D represents the horizontal distance. So that's the distance going across, and then up the side is the H, or the height of the ball. So really, if I was going to draw what the parabola might look like, the parabola might look like something like that. Just extend my axis there. So that's what it would look like there. I'm trying to figure out how far along D does it go when it hits that point there. And what we do know about that point there is that H is equal to 0, because there's no height on the ball when it hits the ground. So we are going to rewrite our equation from up above, but we're going to put 0 in where the H is. So it's going to look like that, and then plus D. So the only thing I've done there is sub 0 in for H. Now, one thing I'll get you to make note of here. So if the constant term is missing, so if there's no number being added on the end here, there's no C value, it's always going to be easiest to common factor. So if we common factor this, D is common to both terms, so we take D out, and that means we're going to get negative 0.25, oops, I'm copying this number down incorrectly, that could be a problem. Let me just fix that. I think that's the first mistake I've made on these videos all year. So I take D out, so I don't want to forget that 0, so it's going to be that, and then plus 1 for the D on the end. So I'm just factoring D out of both those terms. And when I'm solving this situation here after I common factor, from here, D is equal to 0. From here, this thing in the bracket could be equal to 0. And if I solve this equation, so I'll divide by that, the value that I get for D is 40. Now I need to look at my two answers. The horizontal distance for this question is not 0, because that is what it was at the start here. They want to know how far does the ball go before it hits the ground. So we are not going to use this answer, but we will use that answer. That's the correct answer to this question. So therefore, the ball went 40 meters before hitting the ground. And then the last part, Dawson heads the ball as it's on its way back down. If Dawson is 1.85 meters tall, how far is he from the kicker? So let's think about what that looks like on the graph. So it's the same parabola. There's our parabola. Okay. And this time we're trying to find the distance when the height is 1.85. So if that's 1.85, it could be that value, or it could be that value going across. So we're either finding this value or this value. So in this case, same thing we did up above, we're going to substitute in for h, and we know that h is equal to 1.85. So this time, instead of putting 0 in for h, I'm putting 1.85 in for h. So when I do this, it's going to look like that. I'm going to move everything from the right side over to the left side here. And when I do that, it's going to look like this. And once I reach this point, I'm going to use the quadratic formula. So I'm going to pause things here. You guys can try and use the quadratic formula there and see if you get the same answer. All right, it's magic. There's my answer that I got there. Keep in mind, when I say x in this formula, we're also talking about d in our equation up above. So I've got two possible answers, 38.1 or 1.9. They're asking when the ball is on its way back down, so we're talking about this point here, how far is Dawson from the kick? So this is the answer that we need, not that one. So in this case, we're not going to use the 1.9, we're going to use the 38.1. So therefore, Dawson is 38.1 meters from the kicker. And that's our solution for that. All right, so we'll take a look at another example here. Sometimes you're going to get examples where you have to use an area formula. The great news is that you're only going to use the area formula if they give you an area in the question. So in this case, and it's typically going to be a rectangle or a triangle. So those are formulas for area that you know. So in this case here, for this one, a rectangle has dimensions x and 2x minus 6. If its area is 92 centimeters, what is the value of x? And then what are the dimensions of the rectangle? I'm just going to draw a little rectangle over here and just label it with what I know. So if that's my rectangle, the dimensions are x and 2x minus 6, and the area is 92. So because they've given me the area of the rectangle, I'm going to use my formula for area, which is length times width, and then I'm going to substitute in what I know. So 92 is the area. The length here is 2x minus 6, and I multiply that by the width, which is just x. Now, the next step once we start the equation is to expand and simplify and then get it in standard form. So in this case, I'm going to need to multiply that x inside the bracket here. So it's going to be 2x squared minus 6x. So when I move everything over to one side, it's going to look like that. Now, just a pointer to give you here. Even if you plan on using the quadratic formula, you should common factor if possible to get smaller numbers to work with. So in this case, we don't know whether it's factorable in the end, but we do see that every term has a 2 in it. So I'm actually going to factor the 2 out. So that's going to be x squared minus 3x, and what's that going to be? Minus 46 on the end. And so now I've got smaller numbers to work with for the quadratic formula, because I only have to concern myself with what I have in the bracket there, because the 2 out in front isn't going to affect anything. So A is 1, B is negative 3, C is negative 46. So I'll just pause it here and I'll use the quadratic formula, see what we get. All right, so I get to this point here, and I'm going to round my final answers to 1 decimal place here, just for to make things easier to work with. So in my next step here, and in this case, when I round to 1 decimal place, my 2 possible answers are 8.4 or negative 5.4. Now in this case, we're talking about the length of these lines. So negative 5.4 is inadmissible. It's not possible, so we're not going to use that. So that means 8.4 is our x value. So therefore, the dimensions are 8.4. So that's what the x value is going to be, 8.4. Now I need to calculate what the length is going to be there. So if I do 2 times 8.4 minus 6, that's going to give me 10.8. So the dimensions are 8.4 meters, I guess that's centimeters, sorry. 8.4 centimeters by 10.8 centimeters. So your diagrams or your let statements are a big help when you need to find that final answer. You can sub values into those expressions. All right, one more example. This one involves Pythagorean theorem. You'll know that this is not an area question because it doesn't mention the area in the question. So we'll draw a picture of what we're dealing with here. We've got a right angle triangle. We know that the hypotenuse is 26 units. The other 2 sides have a sum of 35. So let one side be x, let the other side be, and we've talked about this before, when 2 sides have a sum of 35, we're going to do the opposite of what we do when we talk about sum. We're going to subtract. So the other side is going to be 35 minus whatever the x value is. So in our, if I was going to label my triangle, that's what it looks like. And in this case, we're going to use Pythagorean theorem. So there's Pythagorean theorem, and I'm going to sub my values in there. So one of the sides is x, so that's just going to be x squared. The other leg, or the other side that's not the hypotenuse, is 35 minus x squared. And then the hypotenuse is 26. So that'll be 26 squared. And now we expand and simplify and move everything to one side. So this is going to be x squared. If you need to write this bracket out twice and do FOIL, you can do that. Either way, you should end up with 1225 minus 70x plus x squared. And on the other side here, we get 540. I'm going to have to check that one. Just one sec. So that is 676 there. I was jumping ahead with my number there, because on the next line, when we simplify things, collect the like terms, we end up with 549 as our C value. All right, we can't, there's no common factor we can take out of here, so we're going to use 2 as our A, negative 70 as our B, and 549 is our C, and we'll use the quadratic formula. All right, so we get down to the end here, we get two possible answers, 23.1 and 11.8. And in this case, we're trying to find those two sides, and whether you use x as 23.1 or 11.8, those are the two numbers you get for the other two sides. So at the end here, in this case, we can just say, therefore, the other two sides are 23.1 and 11.8. And I didn't give you any units there, so we don't need to put any units on those lengths. Okay, so we'll stop there today. We'll practice some of these tomorrow in class, and then we've got a few other types of word problems that we'll take a look at as well. Okay, we'll see you tomorrow.